Hi everyone, welcome to this talk about KICS. And I'll actually start my talk with a sentence from Gartner that says that by 2024, 70% of workloads will be on the cloud. So with organizations becoming increasingly reliant on cloud-based infrastructures and DevOps practices, the need for effective infrastructure as code security has never been greater. The ability to securely manage and automate configurations of infrastructure has become an essential component of digital transformation, allowing organizations to innovate faster and more efficiently. However, with the benefits of infrastructure as code also come security challenges and risks that can have significant impacts on organizations' security posture, compliance, and operations. My goal is that in this talk, you will have a better understanding of infrastructure as code and its security, and how you can protect your organization's critical data and assets using KICS. So a little bit about myself. My name is João Reigota. I'm a software developer, more specialized in Golang, and I'm part of both KICS and DAS teams for Checkmarx. So what is infrastructure as code? Well, infrastructure as code is an approach that allows you to define and manage infrastructure configurations and deployments through code instead of manual configurations. If you think, for example, of AWS console, where you would go and you would create an EC2 machine, infrastructure as code does that, but you write it in code. Like this example here, which we have in Terraform. So infrastructure as code defines infrastructure configurations and provisions through code using tools like Terraform or CloudFormation. It is typically managed through version control systems like Git, and this enables for collaboration. It gives you versioning on the files, and it also gives you some change detection, so you can always see who changed what in the files. Again, collaboration. This is really important because not only collaboration inside a team, it allows for collaboration between teams. Teams can work together to define this infrastructure code, and also they can do some code reviews or whatever they need, because you can think of it as regular application code. And it increases securities because it allows organizations to enforce policies, security policies and compliance policies on these files, like you'll see in a bit using KICS. Just to summarize, there are two types of infrastructure as code. You have the declarative one and the imperative one. The declarative one is usually with declarative languages, and you say, I want this type of infrastructure. This is my desired type of infrastructure, and the provisioner will do all the work and will give you the infrastructure in the state that you want it. And then you have the imperative, where you're going to say which step you need to take so you can get to this point. So, for example, in this example here, we have we're telling Terraform, which is a declarative type of infrastructure as code, to give me an EC2 machine of type T2 micro, and then it's up to AWS to do whatever it needs to give me this. And the imperative, you can think of a shell script there where you would do like the steps in order to get to this machine. But the three main benefits of infrastructure as code, in my opinion, would be speed, cost-effective, and consistency. Speed and cost-effective, they're tied together in a way, because it comes from from infrastructure as code promoting automation. It allows you to really fast, you can deploy your environment using automation, as I said, and this will give more productivity and more efficiency for the developer. So if we think of a test case, a developer, we have an application and we have a production environment, and we also have the testing environment where we will run our tests. Without infrastructure as code, the developer would need to go to the AWS console, would need to push the changes into the machine, into the environment, then it would need to run the tests, and then finally, if everything is running okay, it would need to push the changes into production. So infrastructure as code gives us automation, and with tools, with CI/CD tools, what the developer would be able to do is have this all configured in through this CI/CD, where you push the changes into this testing environment, run the tests. If everything is okay, merge it to master. And finally, consistency. Well, it eliminates the inevitable inconsistencies that will occur when multiple individuals are setting up manually configuring new applications. But while infrastructure as code provides a number of benefits, it also poses security risks and challenges that need to be addressed. One of the most significant risks would be the misconfigurations. Since infrastructure configuration is defined in code, even a small mistake can lead to significant security breaches. We also have vulnerabilities, and these can come in the code or components or in dependencies. And again, they can cause real problems if they are not attended to. Human error. Although infrastructure as code in a way already minimizes human error, it's still written by humans or people, and so it still has human issues. So again, this is also a very important one. And secret management. Infrastructure as code depends on very much on secrets. You can think of database passwords, API keys, anything. And if these are not correctly managed, they can become a big problem. In terms of vulnerabilities and misconfigurations, the most common, I would say, would be open ports, excessive permissions, lack of proper definitions, hard-coded secrets, and infrastructure as code security drift. Open ports and excessive permissions can allow attackers to gain access to resources and sensitive data. The same goes for hard-code secrets. If you have a hard-code secret in your infrastructure as code, and for some reason someone can have access to this file, you have now access to your resource and data because he has the passwords there. Lack of proper definitions. This may be that when there's an issue, your application will have downtime, so it will break. And infrastructure code security drift, this is the change from what you have in the files and what is deployed. So let's say I have an infrastructure as code file, and I need just to do a minor change, and I don't feel like doing it on the code. So I just go to AWS console and I change something. But I just introduced a vulnerability. And from the code, everything seems fine, but what's deployed is different. So this can be also exploited. But these are just a few of the countless, and these are just a few, and there are countless more. And really, it's unreal for a developer to keep track of all of this and all of configurations and all of security best practice for infrastructure as code. So I'll guide you through KICS and how KICS can help you to keep your infrastructure as code safe and secure in a fast development process. So KICS, what is KICS? Well, KICS stands for Keeping Infrastructure as Code Secure. And it's an open source tool that will statically analyze your code, your infrastructure as code, for vulnerabilities, misconfigurations, and compliance issues. KICS has a set of rules that we call queries that will go through your code, as I said, and will find the issues that are in your code. It now counts with 14 different categories, giving it a wide landscape when it comes to infrastructure responsibilities. For example, we saw before Secret Manager. This is a query that we have that looks for secrets and hardcode passwords in your infrastructure. Also, networking and firewall, access control, so on. At the moment, KICS has around 2,500 queries, and these ones are used to cover the categories above mentioned in a variety of technologies. So KICS supports security for everyone. We have security for infrastructure, so this would be Terraform, CloudFormation, and so on. We have for containerized environments, so Kubernetes, Docker. We even have for API specifications like OpenAPI and gRPC, and computation oriented like serverless or SAM, and so on. And the good thing about KICS is that KICS was made in the architecture of KICS actually allows for new technologies to be integrated really easily. For example, if the KICS already supports parsing the files that you want to integrate, it's just a matter of creating the queries and placing there the type of technology that you want to scan. KICS is mainly it's a CLI. It's a Docker image that comes as a CLI, but it's not. It can be run in many other ways. It was made to be integrated everywhere, like CI/CD tools. We actually have an action, for example, for GitHub, and in GitLab we are are an out-of-the-box solution for GitLab security. And KICS we try to make KICS a true shiftware application. This means that you're getting security of your software from the beginning that you start writing your code, from the point that it is already deployed. And for this, I will show in the demos, we'll see KICS working as a plugin in VS Code, and we'll see KICS working, getting the information from what's already deployed. So now I will skip to the demo. Just a second. Oh, okay. So now let's go over the KICS demo.
You have to change it on that screen.
Sorry, just a second.
It's on the live stream.
Okay. So how do you get KICS into your machine? Well, KICS is a Docker image. You simply, I don't know if you can see, it's a little bit small, but you just simply pull the image like a regular Docker image. So I already have it, so it was really fast. Now that you pulled KICS, you're already ready to start the scans. So to run, you run as a regular Docker image. So we're going to do Docker run. We're passing in the volume. We're passing this project that we are trying to scan, which is Kubernetes Goat, and we're giving it to a volume of internal Docker called path. We then say run the command scan, call the -p flag, which is the path flag, what we want to scan. So we want to scan the volume that we just created. We also say that we want to have reports in this volume with a -o flag, and we want JSON and HTML reports and give the name report. So let's run now KICS, and KICS will give you like a nice image. And we're running version 1.6.14, and now it's preparing scan assets. So what it's doing now, it's actually looking through your project, and it's seeing which files are infrastructure as code, which files are not, and those files want to be ignored. And then it's getting all the queries and the parsers that we'll need. So, and obviously then it starts executing the queries, as we can see. While this is executing, KICS releases in 2 weeks. So every 2 weeks, we actually release a minor. Major releases usually take more time. So KICS has finished with the results. It's still generating HTML report because it takes a little bit longer, but we are already able to see the results in our console, in our CMD. And we can see in the bottom, we have a result summary with a high, medium, low info and total results. So we get all that information. And from the image of the results, so each one of these is a query. So as you can see, this is a query, and then you have each result for that query. It gives you the severity, the number of incidents that happen, and a description of the query, the platform, and the file where you're getting everything, where you're getting your issues, as well as the line and the code snippet that you can find. So KICS finished doing the reporting. As you can see, it's in the folder that we gave it. And let's open the report HTML, which is another type of report. You have multiple reports, report types that you can have. So opening report HTML, it gives you the same information, but in a different way, and it gives you a little bit more, actually. You can filter by which type of result you want, which type of severity, I mean. And if you see, we now have also the category. And besides the description, we also have a link that will help you fix your issue. And again, we have also, this wasn't before, but we have now expected and found. So what it was expected to have in order not to have this vulnerability, and what was actually found. And as you can see, you have also the code snippet. And above, you also have the version, some information like start time and end time, and yeah, and the platforms that it found. So it actually found Kubernetes, Dockerfile, and Common. Common is usually passwords and secrets, which is the only query that we have that is not written in Rego. It's a query that's written in Go, and it finds in any type of file. Okay, so now I will show you the VS Code plugin. And what this VS Code plugin does is it will look to your file that you have open, and it will see, is this an infrastructure as code file that KICS supports and can scan? And if so, KICS will start a scan, and it will try to find vulnerabilities and issues in this file that you have open. So how are you going to install this file? So you need to go to extensions. As you can see, you type Checkmarx, and you can add this extension. You can install it. Let's wait a little bit. And that's it. Now you need to go to the settings. And in the settings, where it says Checkmarx KICS auto scanning, you have this checkbox. This needs to be active in order for KICS to make auto scans. So be sure to have that. And then you also have KICS additional parameters. This is because you can add any flag that KICS has, you can add it here, and it will help you like change the way you're running scans. Like you can ignore files, or you can ignore queries. It gives you a lot of freedom in that way. So we're now going to open a Docker file, and KICS will start doing the scan. So we have here a Docker file, and we have here an issue, which is add instead of copy. And if you look at the bottom, it says open the support file by KICS, starting KICS scan. So KICS already detected that this file was supported, and now it's starting a scan. And the scan is finished, as you can see. So it gives us the result summary in the bottom. You can check how many results you have. It also gives us where you have the line that you have results. It underlines it with a different color for different severities. And if you hover over this line, you will have more information on this result. So as you can see, you will be able to get the description, you'll be able to get the value where the issue was found, and a recommended fix on how you can change this. So here it's add instead of copy. You can see the recommended fix is actually saying, look, change this to copy. And it gives you this, like this is the same view, but yeah. But in here also comes a new feature that KICS has, which is the auto remediation. So this is still very new and still doesn't work for everything. Right now it's just working for Terraform on a few queries, and it actually only does additions and not replacements, but it changes things. For example, a flag that's true, it changes it to false. And this feature, the auto remediation feature, actually allows you to fix your misconfigurations and issues that you might have, and it fixes your whole file without you even having to worry a lot. So let's do this scan. Just waiting a little bit here. Okay, so I'm gonna skip a little bit forward. Okay, so to do this scan, we need to do it on Terraform. Again, as I said, it's only supported to Terraform right now. So we open this one, which is Dynamo table not encrypted. And now KICS already detected that it's a Terraform file, and it's scanning it. Okay, just a little bit for the scan to finish. The scan is finished, and as you can see, we have 4 infos, 1 low and 2 medium. And the difference from what happens when you have a fix that you're able to, a result that you're able to fix, is that in the end, where it says you problem, you also have the quick fix one. The same way that you have, for example, for other plugins for VS Code. So in here, if you click quick fix, and you can click, you can fix only one at a time, or you can fix all of them. So we're going to apply all available fixes. And KICS now starts doing these fixes. He's looking at what he needs to change. And here we go. It just made the additions. In the output folder, you can see it's saying the number of available remediations that it has. So it was at 4 and was able to apply all 4. And just to show you that, in fact, the changes were applied on the entire file, we can go here to the changelog, and we can check that indeed it was added. So, for example, for this Dynamo table, we didn't have a point in recovery, which is now enabled. We also didn't have server-side encryption, which also is now enabled. So this one was an addition. For the second Dynamo table, same thing happened. There wasn't point in recovery, so KICS added it. And we had server-side encryption set to false, and KICS made the change to put it to true. And yeah, so this is it for VS Code. And I've showed you so basically this was shift left, so starting of development of infrastructure, defining the code. And now I'm going to show you the most shift right, which means is we're going to see KICS getting actually the information from cloud or from a cluster and creating the infrastructure as code and actually scanning them. So I'm going to skip here a little bit forward. So for this, we actually have two tools. There is Terraformer, which is an open source tool that we integrated into KICS. And there is Kubernetes. This is one that we implemented. So Terraformer supports, for now, KICS integration with Terraformer supports AWS, Azure, and GCP. And what Terraformer does, it connects to your to AWS, and obviously you need to give him access for it to be able. And you tell them, look, describe me these resources, or describe me this what I have in this region, for example. And it will give you that information, and then Terraformer will build the Terraform files. Then it's just up to KICS to scan them and give you information on security issues that you already have on the environment that is deployed. And Kubernetes is doing something similar, but it's actually asking the cluster, the master node, and it's giving, like, give me information, and the master node already gives it in Kubernetes files, and then KICS actually does the scanning. Again, we need to have access to both the cluster or AWS environments in order for this to be possible. So you need to pass some information, and there is like a pre-work that is needed. So in our case, we're going to do a demo using Kubernetes. We're going to access a cluster. Skip here a little bit to the front. Okay, so let's go over here. I'm actually going to pause it. Okay. So here as you can see, we're passing in environment variables. We're passing the Kubernetes host, certificate data, and service account token. And we're saying, look, scan, but now in the -p flag, we're not giving it a file. We're giving it a different syntax. And this is a syntax. It's the same for both Terraformer and Kubernetes. And now to show you a little bit of the syntax, what it says is you can specify what you want Kubernetes to get. So you will say, the start is always the same, is always Kubernetes, and then you can specify which namespace you want, or which API versions, or which kind. If you want to get everything, you can do an asterisk. And here in the documentation, you will have some information on the kinds that Kubernetes actually supports. So here you have an example. Okay, so let's do the scan. Actually, we also want to get the report information and all of that. So okay, yeah, and as you can see, we're gonna ask for everything. So we started the scan. KICS connected to the machine, and here what this is, it's getting the information from the cluster, and then it presents you with the results. So this can help you also in a security drift, because you can get information on what issues of security issues you actually have on of environments that are already deployed. So now I'm going to go back to the presentation. This was it for the demo. Okay. Just a second.
You got it here?
Okay. Okay. So KICS has around 2 years, and in these 2 years we had great contributions. We already made 1.5 million downloads, and we're able to get to 1.5 thousand GitHub stars. It is complete. It will help you find security vulnerabilities, compliance issues, misconfigurations in all your popular infrastructure as code tools. And it is also extensible, which means that it has more than 2,000 queries, which are very easily to edit, extend, or add. It has a simple architecture, and it enables easy support of new infrastructure as code technologies. So what's coming in the future? Well, we want to do an integration with ChatGPT. And what this will give you is when you run a scan, you can actually talk with KICS and ask him, look, how can I fix this issue? Or give me more information on this result that I have. And KICS using ChatGPT will give you more information. Besides that, we also have a number of new things that will come. Some integrations. We have Arbor, CloudFormation hooks. We're still going to give coverage to the tools that already exist, and we still try to expand on them. And we're even doing different things like pipeline security analysis. So we're actually looking at pipeline files and checking them for security. So this was my presentation, my talk. I would like to thank you. If you want, you can take a picture and then you can take a look at the websites here from KICS. If you have any questions later on, you can send me an email or send an email directly to the KICS email. And if you have any questions, I can answer them. Thank you.
We have some time for questions. There's a question, okay.
So thank you for the presentation. First of all, I'm curious if you could show some of the rules or that KICS uses to, I don't know, some of. I'm interested to see how those rules are organized and how can anyone contribute in that some of those rules. And by the way, how do you maintain? Because 2,000 rules, I guess that's a lot of rules. You also have a community. That's probably one of the reasons why it's open source. And but if you could show some of those rules, that'll be interesting. Thanks.
Yeah, so what you said was exactly true. Like 2,000 rules, it's really hard to keep track of, and we actually have very much like issues with rules and everything. Also, it's the community that says, "Look, you have an issue here," and then we are able to fix it. But looking at the rules, so here in KICS main repository, you can go to assets, and then we have queries and libraries. Here you have a template which on how you can create a query. So if you want, you can take a look. And this is like the way that a query is built, right? So this is a template that doesn't look at anything, but I don't know if you have some knowledge on Rego, but what it's doing is every step. So every step here, if it has anything, then it will stop execution and it won't continue. So let's say here you have a comparison. Yeah. If this is not the same, then it will stop it execution. So when we want to find a security issue, what we do is we try to see if the issue is there. So let's say, let me try to find a query which is easier to see. So here in the queries, you have all the types that KICS supports. I think we can go to like Terraform, which are the most popular ones.
You can, You're not sharing
Ah.
the presentation.
Sorry.
Maybe changing the other window.
I think I can share like this. Okay.
If you could also zoom in, that'll be
Yeah.
perfect. That'll be perfect.
Okay. So in Terraform, then you have like providers. So if you go like AWS, and we can choose one. So like AMI not encrypted. And if we check the query, okay, so what it's doing, so KICS actually transforms your infrastructure as code into a payload, a JSON payload. And this is how we're able to go through the infrastructure as code file and check if there are any vulnerabilities. So this input.document I is always the same. So this I is an array actually. And then you're going through resource. Let me see if I can put like, I can show like here, the Terraform file so we can follow along. I think it will be easier. Okay. So when we're saying, give me a resource, which is type AWS AMI and any name. So go through the array. So when we're looking here at the queries, we have resources. So this is a resource, then it goes through AWS AMI, and then it's looking for each name. So it's looking for +1, +2, and then +3. Then we're saying in this resource, check if EBS block device is encrypted. EBS block device, which has an object value of encrypted. Check if it's equal to false. So it's looking for EBS block device, which is got here. This one doesn't have. And then it's checking the encrypted one. If this is equal to false, and which it is, then give me the result. And this is where you define everything that has to do with the result. So we have two types of the saying where the line that has the issue is. We have the search key and search line. So search key uses Levenstein distance to find the most correct similarity, but it has some limitations. So we actually also implemented search line, which works a little bit like JSON path, where it goes through resource and same way that the Reigota does. It goes through the objects and its values and points you to the correct line. And then here you can set all of information and also the remediation, as you can see, where before was false and now is a true. So we actually have in the documentation, I will open it here also. Sorry, wrong bookmark. So in the documentation, we actually have information on all the queries. And you can just go to any query, to any platform, I mean, any technology, and you can check like each query and you can press the documentation. And it will take you to, in this case, AWS serverless. So you can get more information on what's the issue that you're actually having. And besides that, it also has how you can create a query in a better way that I can explain. But after you get the hang of it and you try with small queries, it becomes really simple.
Can you go back to the Reigota file, just out of curiosity?
Yes.
So on line line 15, that common lib.build search line, that's arbitrary. You're calling a go function there?
No. This is actually Reigota also gives you the option to have libraries, and you can see here on line 4, we're actually importing this library, and this library comes from assets. Here in the assets, you have here the libraries, and then you can, in this case, it's Terraform, I believe. So, it's common, so it would be from here. So you can call functions from this library directly. So it's just for us to not have too much duplicated code.
But this is Reigota all the way, right?
Yeah, this is Reigota.
So it's like Prolog, like there's no...
Yeah, like
Okay.
the only query that we actually have that it's written in Go, which is the password and secrets query. Let me see if I can find it, which is this one. As you see, this one doesn't have any Reigota inside it. It has this regex rules because we use regex, and you can actually change this file or modify this file to be able to find for specific passwords, or you want to ignore sometimes that can happen, like passwords are really difficult to determine. So you can have some false positives and you can come here and eliminate them. Just trying to find where we specify the passwords and secrets query, but I believe it should be yeah, I don't remember where it was.
No worries. Thank you. Any other questions? So maybe I can ask a couple of questions. So this is stateless. Or do you have some notion of state among different runs of KICS?
On KICS, on this one, no, it's stateless. So each time you run, you get the results. We also have KICS, which is in the enterprise version, KICS in the CX1 product, and there you have state. You're able to keep track of your results and check which results are recurrent or new. So you get that information.
Okay. So if I run it as a GitHub action, basically I get the report and then I can feed it into a pull request, for example?
Yes. I think I can show you here an example where KICS would run the GitHub action. Not this one. But here you can see like KICS ran the scan in the GitHub action, and it gives you information on the results, gives you the version, and gives you all of this. And you can actually, if I show you here, the GitHub action, I don't actually have here. Let me see. Easier this way, sorry. Trying to get to the GitHub action. So if you see here, you're able to get a lot of information from this. Also, you're able to get reports in various formats. It's basically, since KICS runs as a Docker image, you can run it. You can basically do the same thing, the same flags that you run regularly, you can run in GitHub action. And this, like, it's a two-step action. It first runs with Docker, so it runs the scan, and then it has some JavaScript to give you some comments and in your pull request where you can see where the results are and where you got those issues.
So you basically take the report and then you have a second step where you feed the report into the pull request.
Yes.
Okay. Yeah, that's kind of nice. So why Rego?
It was what was chosen at the time, and I believe it was because it was a simple language that you could start to implement. It was very simple for someone that doesn't have like for example, knowledge in Golang or something. Like, it's easier to get to Rego. You can, like, 3 hours, you get like everything there is to know about Rego, and then you can easily start implementing queries. So yeah.
Okay. What are some of the limitations that you cannot do in the queries because you're doing it with Rego?
With Rego that I can think of right now, I don't remember a lot of them. Like, everything that's like resolving, it's like some kind of issue, but this is not directly related to Rego. It's more directly related to how we're doing the parsing, but resolving files and doing, everybody expects, okay, like I feed this and I hope that it scans everything. So we need to resolve all the files, get all this information, and then we scan with Rego. And Rego, the only thing, the downside that I would say is that it can take like sometimes a lot of resources, and it takes a little bit, but in the end, it still gets the job done.
Okay. These vulnerabilities are intra-file, right? Or can you spot vulnerabilities which are across multiple files?
Yeah, you can. There are some queries that will look through multiple files. So you have some query Regos that. So basically, what we do is we parse the whole project into one file. There's actually a flag where you can see this file, and what it's doing with this whole file, it's, as you saw, it's looking like on each step. And basically, if let's say we have like, for example, a bucket that needs a policy that is in another file. What we'll do is we'll get this bucket, and then we will check if this policy that it's saying exists, and then it can be on any other file. So there is multiple files vulnerabilities, but these are usually very complicated because of the issues that are involved. Like you could have, let's say, two different infrastructure as code projects in the same repo, and KICS won't be able to differ on which one is who. So yeah.
So you get false positives because of that.
Yeah, sometimes yeah.
Okay. Okay. Last question before we conclude. When you do the drift analysis, can you do a check on what is in, for example, an environment and what is on your, for example, GitHub repo, and find out if there is like differences, or is it possible to do? Because that's super useful, right? Because
yeah, we actually started doing that, but we later left it, and two reasons actually. Like the first one, the Terraform tool, although it's good for what we want, it's not optimized, and it needs some work on it, and it has like a lot of providers that we don't actually use anymore. So like we decided not to use that part, and we decided to left. It was a whole new project. It was a whole new project that we had, and yeah, because of this, because of the problems that were coming, like we were trying to do for all infrastructure as code types, not just Terraform, which Terraform only gives you Terraform, and Kubernetes only gives you Kubernetes, and we saw that we were not being able to do it, so we dropped it. But yeah, there is the possibility that you could get the information from what is on the cloud, and you could double check it with what is in the files. But again, it's a very complex situation, because also what you have in the infrastructure as code files sometimes is not all resolved. It can have some references to some things that are already deployed, and when you get from the cloud, you get all the information, and you need to check if it makes sense, the comparison you're making, because of this and other stuff like that.
Okay. And so just to finalize, sorry, this ChatGPT thing that you have, what can you say about how many rules can you just drop because the GPT engine already knows about them?
Yeah, so right now we're still on POC, so we're still testing it. And what we decided is that we don't want to send the information to ChatGPT, because you're actually sending like results and vulnerabilities. So what we're giving is to whoever using KICS to be able to send whatever they want through KICS, like related to this. It's still very much on POC, so we're still figuring it out. So yeah.
Okay. All right. Let's thank again.
Thank you.
All right. I think there is no beers.
Oh.
But there's beers if you want to.
Yeah.